This will be helpful today as we cover information for tomorrow's Unit 5 Part 2 exam. We will be referring to these rules. You were provided this in the last couple weeks. Okay, on your blank piece of paper, please go second plus 712 on your graphing calculator. Second plus 712. Your first problem looks like this. It is y equals 2x squared over x squared minus 9. In order to get through everything today, I have to move very quickly. Okay, what is a horizontal asymptote here? We take the bottom, we set it equal to 0, and we solve. X squared minus 9 equals 0. I add 9 to the opposite side. It becomes positive. I take the square root to eliminate the square. This also tells me I'm going to have two answers, in this case plus or minus 3. A common mistake is students want to write 3 and negative 3. You have to write the asymptote as an equation. It is x equals 3 and x equals negative 3. For this problem, the degree on top is the same as the degree on the bottom. You're welcome to refer back to these notes right now. You're welcome to refer back to these notes. When the degree on top is the same as the degree on the bottom, we're going to circle the coefficients. And this will tell us what our horizontal asymptote is. Horizontal asymptotes always start with y equals. So in this case, it's 2 divided by 1, which is 2. All right. We only have a slant asymptote, and not always, but the only chance of it ever occurring is if the number on top, the degree on top, is larger than the degree on the bottom. If that's not the case, we write NA. Don't just leave it blank, because you get points for recognizing that no slant asymptote occurs. So I'm now going to come down below, and I'm going to graph the horizontal and vertical asymptotes. So I'm going to go to y equals 2, and x equals positive 3 and negative 3. And I can see, using this as a Miss Bradley term, it's not a technical math term, I can see it appears like there's 6 rooms in this graph. Okay, let's let the graph do the work for us now, the graphing calculator. Go up to y equals, hopefully you've cleared it, second plus 712. And we're going to do parenthesis 2x squared and parenthesis divided by parenthesis x squared subtract 9. And then graph it. Now the nice thing in this form is we can identify the zeros by taking the numerator and setting it equal to 0 and solving. So I'm going to divide both sides by 2, and 0 divided by any number is 0. And yes, in order to eliminate the square, we need to square root both sides, and there would be 2 answers, but there's no such thing as positive and negative 0. There's only just 0. So the x-intercepts are 0. You can write x equals 0, or you can write it as an ordered pair, 0, 0. Either answer would be fine. So I'm going to come down below, identify the x-intercept with a dot. Now, this is the cool part. I get points for showing my work here. It's kind of mindless. We're going to let the calculator do the work. So look and identify the vertical asymptotes. 2 to the left. So 2 places to the left would be negative 4, negative 5, negative 4, and negative 5. 2 places to the right would be positive 4 and positive 5. And then in the middle, I need negative 1, negative 2, and positive 1, positive 2. Now, for the purpose of getting through this fast today, I'm only going to show you briefly how do we do this on the calculator with a few of them. You go second, trace value, type in negative 4, and you get an answer. I'm going to round to the nearest tenth, negative 4.6. I'm going to have you write down these other answers just for the purpose of time. And this should have been a positive, excuse me. 3.1, 4.6, 3.1. And I could achieve all of these ordered pairs using the graphing calculator. This is you showing your work. Now I'm going to come down below and we're going to graph those points. So I'm going to go over 4 and up 4.6, approximating where that is. 5 and 3.1. And as I graph it, remember to include arrows, showing it's getting closer and closer to our asymptotes. then in the middle. This is a 10-point problem. 10 points for this problem. You get points for this, you get points for graphing it accurately. Now we're going to come up and do the domain and range. So domain. The only thing that stops you for a domain is your vertical asymptotes. So it comes from the far left, which is going to be illustrated with a negative infinity. And it keeps coming until it hits what, sorry, it doesn't hit, it approaches what wall? -3. Now it jumps over that wall and starts again after -3, and it keeps going until it gets to and approaches what next wall? +3. Jumps over and goes from 3 to +infinity. If you wrote your answer like this, I would totally accept it. If you want to be more accurate, you can put these and symbols in between. The range, there's no limit how far it comes from the bottom, and it continues to come upward until it actually gets to what y value that it touches. And because it touches it, we're going to put the symbol on. Now here's the tricky part. I'm going to use this just to show you. You don't have to do this on the graph. Do you see how we have all this like dead space in here? So really, the next time the graph starts is after this wall. What is the number of this horizontal wall? Okay, it starts up again after 2. That's why we have a parentheses, because it doesn't actually touch there. And then there's no limit how high it goes. Okay, negative infinity to positive. As I go to the far left, it's approaching the number y equals -2. As I go to the far right, it's approaching the number y equals +2.